Am I audible?
Yes, ma'am.
Yes, ma'am.
No, your voice is not coming to me. Let us see.
Hello. Hello.
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. So today, first of all, we are going to revise whatever part we have seen yesterday. Then we will solve some examples based on Hasse diagram. Okay. So yesterday we have seen what is the concept of partition and covering. So what is meaning of covering? It should cover all the elements of given set. And what is meaning of partition? There should not be any element common between two subsets. That is called as partition. So based on that we have already solved some examples. After that, we have seen what is partial ordered relation. So, what are the properties that should be satisfied by partial ordered relation? Three properties are there.
Reflexive, antisymmetric, and transitive.
Yes, reflexive, antisymmetric, and transitive. That is RAT. Then only that relation is called as partial ordered relation. After that, we have seen what is meaning of partial ordered set. Okay, so if we apply partial ordered relation on any set, then that set is called as partially ordered set. Simply, a set with partial ordered relation is called as partial ordered set. So, in short, we can call this one as post set. That is partially ordered set. Okay. Now, next concept was toe set. That is totally ordered set, or this can be called as chain. So why this one is called as chain? So if there are two different elements x and y, now suppose x is less than equals to y or y is less than equals to x. Means what? These two elements x and y are related to each other. Now consider the first case where x is less than equals to y. So Here we can say that these two elements x and y are related to each other, and these two elements forms a chain. That's why this one is called as toe set, totally ordered set. Okay. So again, after that we have seen what are the examples of partially ordered relations. So first one is less than or equals to, greater than or equals to. Second one is inclusion, that is all the set of power set. And third one, divides an integral multiple of. So all these are called as partially ordered relation. Though this symbol looks like less than equals to, but meaning of this symbol is partially ordered relation, and that relation can be anything like less than equals to, greater than or equals to, inclusion, integral multiple of, or divides. Okay. So after that we have seen what is the partially ordered set. So we have already seen what is the meaning of poset. So any set with partially ordered relation on it, that is called as poset. Okay. So whenever we have to represent this poset, we can represent it by one diagram, and that diagram is called as Hasse diagram. So here we have defined Hasse diagram. A partially ordering on a set P can be represented by means of a diagram, and the diagram is called as Hasse diagram, or we can say it is partially ordered set diagram. Okay, so we can represent any partial ordered relation with the help of diagram, and that diagram is called as Hasse diagram. Then there are certain rules how to draw a Hasse diagram. Those are listed here. In such a diagram, each element is represented by small circle or dot. So all the elements of that diagram should be represented by small circle or dot. This is the first rule. Second, the circle for x belongs to P is drawn below circle for y belongs to P if x is less than y, and a line is drawn from x to y if y covers x. So this is the very important rule to draw a Hasse diagram. Suppose there are two different elements x and y, and x is less than y. Okay, so we have to fix now what is the position of x. Now here x is less than y, so we should draw the circle for x below circle for y, and we are going to connect these two elements by a line if and only if y covers x. Okay, so consider here 4 elements are given, so this should be represented by 4 circles. Okay, now consider this relation is less than. So 1 is less than 2, that's why 1 is below 2, and these two are related, or these two are connected by a line because these are satisfying the given condition, that is less than. Again, if you observe 2 and 3, again 2 is less than 3, that's why position of 2 is at below 3, and these are connected by line because 2 is less than 3. Again, if you consider 3 and 4, 3 is less than 4, so 3 is at below at 4, and these are connected by single line. Okay, so likewise we can say that this set P is consist of 4 elements 1, 2, 3, 4, and partial order relation is less than. Okay, so this is the Hasse diagram for same. So do you have any doubt up till now? हॅलो, जर काय समजलं नसेल तर सांगा, नाही काल सारखं व्हायचं, लेक्चर संपत आलं तुम्ही सांगणार की समजत नाहीये म्हणून. रिपीट करायचं का काही? हॅसे डायग्राम म्हणजे काय समजलं का?
रिपीट करा मॅम.
कोणता पॉइंट रिपीट करायचं आहे?
Hatch point, ma'am.
Has a diagram.
Yes, ma'am.
Okay. So first of all, we have to see what is the purpose behind drawing this Hasse diagram. So up till now we have seen what is the partial ordered relation, what is the poset. Now if you want to represent any partial ordered relation, you have to draw any diagram and that diagram is called as Hasse diagram. म्हणजे काय एखादं पार्शल ऑर्डर रिलेशन जर तुम्हाला रिप्रेझेंट करायचं असेल डायग्रामॅटिकली तर त्या डायग्रामला हॅसे डायग्राम म्हणायचे. सो वेन एव्हर वी हॅव टू ड्रॉ एनी हॅसे डायग्राम देअर आर सर्टन रूल्स. First one, each and every element of that Hasse diagram should be represented by small circle or dot. Okay. So if you consider this example, here P less than equals to, this is a poset, that is P is a set, and here less than is a partial ordered relation that is applied on this set P. So again this set P is consist of 4 elements as 1, 2, 3, 4. So according to the first rule, we have to represent all these 4 elements using circles. So here we have represented it 1, 2, 3, 4. So 4 circles are there. Now we have to finalize what is the position for these 4 elements. Okay. Now here they have mentioned this relation is less than or equals to relation. Okay. Now we have to see 1 is less than 2. That's why we have to place this element 1 below 2. Okay. Again 2 is less than 3. That's why we have to place this element 2 below 3. Again 3 is less than 4. So we have to place this element below 4. Now if you observe, all the elements are placed at proper place because these are satisfying given condition, that is less than or equals to. That's why we have connected all these 4 elements. So this is the Hasse diagram for set which is consist of 4 elements 1, 2, 3, 4 and relation is less than or equals to. Okay. So this is just one example for Hasse diagram. Now we have to solve some more examples. हे example समजले का? काय केलं?
Yes, ma'am.
Okay. Now consider second one. Here set P is given which is consist of 4 subsets. First one is phi, second one set A, third one set A comma B, fourth one is set A comma B comma C. Okay. And here relation is given as subset relation or inclusion relation. Means what? We are going to connect all these 4 elements if those are subsets of another set. Okay. So first of all, it is final that we have to draw 4 circles because this set P is containing 4 elements. So first circle is for phi, second one is for set A, then next one is for set A comma B, and last one is for set A comma B comma C. Now we have to see what kind of relation we have to apply on this set. So they have given in question itself that we have to apply relation of inclusion or relation of subset. Now phi is subset of set A. Yes, because phi is subset of every set. That's why we have connected here phi and set A because phi is subset of set A. Now next element is set A comma B. So here set A is subset of set A comma B. That's why we have connected these 2 elements. So again phi is subset of set A comma B also, but we have connected this as phi to set A and set A to set A comma B. So it is not required to draw direct line from phi to A comma B because they are already connected through set A. Now next one is set A comma B comma C. So now we can say that set A comma B, this is a subset for set A comma B comma C. That's why we can connect these two elements. Okay. So again, all these four elements forms a chain. So this set is called as totally ordered set or TOE set. TOE set म्हणजे काय? जर ते इलेमेंट कनेक्ट करून जर चेन तयार होत असेल, एखादी स्ट्रेट लाईन येत असेल, then that is called as TOE set or chain. Have you understood this example?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Now, next one, set X is given and that is consist of elements 2, 3, 6, 12, 24, 36. Okay. So this is the given set and on this set we have to apply a relation, divides relation. So we have to connect X and Y if X divides Y. Then we have to finalize what is the Hasse diagram for this set. Okay. So first, how many elements are there? 1, 2, 3, 4, 5, 6. So 6 circles should be there. First element is 2. So here we have drawn circle for 2. Next one is 3. Now we have to decide what is the position of 3. Whether 2 divides 3? No, that is not correct. That's why we have to place 3 at another position. If you place 3 above 2, then what is meaning of this? 2 divides 3, but that is not the case. That's why we have to place this 3 at another position. Now, next element is 6. So, here 2 divides 6 and 3 divides 6. That's why we have to place 6 above 2 and 3, and there should be line from 2 to 6 and 3 to 6. So what is meaning of these lines? 2 divides 6 and 3 divides 6. Okay. Now next element is 12. So again 6 divides 12. So again here 2 divides 12 and that is covered here through this root as 2 to 6 and 6 to 12. So it is not necessary to draw a line from 2 to 12. Okay. Now next one is 24. So here 12 divides 24 and next one is 36. So 12 divides 36. So if you observe here 24, this is the highest element 24 and 36. So 24, 2, 6, 12 and 24 is. So these are the dividers of 24 and that is correct. Again if you check for 36, 3, 6, that is 2, 3, 6, 12 and 36. So these are the dividers of 36. So here we can say that whatever diagram we have drawn, that is correct because it is satisfying given relation, that is divides relation. Have you understood this problem?
Yes, ma'am.
Yes, ma'am.
So next question, here one set is given, that is P of A, that is power set of A, and a relation is a subset relation. Okay, so first one is given as A is equals to set A. So first of all we have to see what is the power set of A. So this is consist of only one element. So power set will contain two elements, that is phi and set A. Now phi is subset of set A, that's why we have connected these two by direct line. Now next example, here set A is consist of A comma B, that is two elements. So its power set will consist of four elements, phi, set A, set B and set A comma B. Again phi is subset of set A, phi is subset of set B and set A and set B, these are subsets of set A comma B. That's why we have drawn diagram like this one. Now, if it is consist of 3 elements, your power set will consist of total 8 elements. That is 2 raised to 3, that is equals to 8. Again, first element is 5. Then second element is set A. Then next one is set B. Next one is set C. So again, for this set A comma B, set A and set B, these are the subsets. That's why we have connected these two by direct line. Again, for set A comma C, set A and set C, these are the subsets. That's why these are connected by lines. And for set B comma C, set B and set C, these are the subsets. So these are connected by lines. And for final set, that is set A comma B comma C, we can say that set A comma B, A comma C and B comma C, these are the subsets. So these are connected by direct lines. So this is the Hasse diagram for any set if that set is consist of 3 elements. So yesterday I told you to draw a Hasse diagram if your set is consist of 4 elements A, B, C, D. So have you tried? ट्राय केले का कोणी ड्रॉ केले okay no response means you have not drawn it. So consider next example. Let A be the set of factors of a particular positive integer m and let less than equals to, that is partial ordered relation, be a relation divides. So this is the divides relation. So how they have defined this divides relation? This is equals to set of order pairs x comma y such that x belongs to A and y belongs to A and x divides y. Means what? Those two elements x and y should belong to A and x divides y. This condition should be satisfied, then only we can draw a Hasse diagram. So draw the Hasse diagram for m is equals to 2. So first of all we have to find the elements those can divide 2. So for these two there are 2 elements. First one is 1, second one is 2. Those can divide 2. So these 2 elements are represented by circle and 1 divides 2. So this is satisfying given condition, that is divides. So this is the Hasse diagram if m is equals to 2. So have you understood how we have drawn this first diagram? Hello?
Yes, ma'am.
Okay. Now next one is m is equals to 6. Means what? Again we have to find what are the elements those can divide 6. The 6 divisors kon hai? First is 1, second one 2, then 3, then 6. So there are total 4 elements. So 4 circles should be there in Hasse diagram. So first element is 1 and that we have placed here. Now next one is 2. So 1 divides 2. That's why we have connected these 2 elements by a direct line. Again 1 divides 3. So we have connected it by direct lines. And next one is 6. So again 2 and 3 both divides 6. That's why we have drawn these 2 lines. So this is the Hasse diagram if value for m is equals to 6. So likewise next one is value for m is 30. So first of all, we have to find what are the divisors of 30. So what are the divisors of 30?
One, two, three, six, five,
1, 2, 3, then 5, next one,
six,
6, then
seven,
10, next
12,
10 नंतर काय येईल 15,
12,
12. How it can be 12? 12 divides 30? No. So after 10, 15 will come and then 30. Okay. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So your diagram must contain 8 circles. So let us start with the first element, and that element is 1. So 1 is represented here by circle. Now next element is 2. Now 1 divides 2, that's why 1 and 2 are connected by direct line. Next element is 3. So 2 cannot divide 3, but 1 divides 3. That's why 1 and 3 are connected by direct line. Next one is 5. 1 and 5. These are connected because 1 divides 5. Next element is 6. So for this 6, 2 and 3, these are the dividers. So this 6 is connected to 2 and 3. Next element is 10. Now 2, 5, these are the dividers of 10. That's why these two are connected by direct lines. Next one is 15. Now for this 15, 3 and 5, these are the dividers. So these are connected by direct lines. And last element is 30. So for this 30, 10, 6 and 15. All these are the dividers. So this is the Hasse diagram if value for m is equals to 30. So for this Hasse diagram, you have to solve some examples on your own. Then only you can draw the diagrams correctly. Have you understood how we have drawn this diagram? जर काही डाऊट असेल तर आत्ताच विचारा. समजले का ही डायग्राम? Okay. So next value for 12 is m is 12. So first of all we have to find what are the dividers of 12. So 1, 2, 3, 4, 6 and 12. These are the dividers. Now we have to draw Hasse diagram for same. So first element is 1. 1 is drawn here. Now 1 divides 2. So 1 and 2 are connected. Then 1 divides 3. So 1 and 3 are connected. Now next element is 4. So here 2 divides 4. That's why position of 4 is above 2. Okay. And these two are connected by a line because 2 divides 4. Okay. Next one is 6. Now here both 2 and 3 divide 6. That's why there is line from 2 to 6 and 3 to 6. And last element is 12. Now 4 divides 12 and 6 divides 12. That's why this is the Hasse diagram for m is equals to 12. पहिल्यांदा तुम्हाला त्याचे एलिमेंट फाइंड करावे लागतील की व्हाट आर दी dividers of given set or given number, and then you can draw a diagram. So likewise next one is m is equals to 45. So can you try for this example? Take 5 minutes. First of all find the elements, those can divide 45 and draw a diagram. and send that diagram on WhatsApp. So I will come to know whether you are getting this or not. So first of all, find the dividers of 45 and then draw the diagram. Yes, that is correct. Whatever you have said, that is correct. First, it is 45. So first of all, we have to find what are the dividers of 45. And those are 1, 3, 5, 9, 15 and 45. Okay. So first element is 1. So next one is 3. 1 divides 3. So we have connected these by direct line. Then next one is 5. So 1 divides 5. So again these two are connected by line. Next element is 9. So 3 divides 9. That's why position of 9 is at above 3. Again these two are connected because 3 divides 9. Next element is 15. Now here for this 15 3 and 5 both are dividers. Okay, so 3 to 15 and 5 to 15. And last one is 45. So again, for this 45, 9, 15, these are the dividers. As well as we can say that for this 45, 9, 3, 1 and 15, 5. All these are dividers because these are connected by a direct lines. So this is Hasse diagram if value for m is equals to 45. Any doubt? Sonal, whatever diagram you have sent on WhatsApp, in that diagram there is one mistake because you have connected 5 and 9 by direct line, but 5 is not a divisor of 9. That's why that is not correct. Rahul has sent correct. Vishakha, yes, that is also correct. 1, 5. Yes, that is correct. So now let us see next question. Draw the Hasse diagram of following sets and indicate under the partial ordered relation divides and indicate those which are totally ordered set. So first set is given here 2, 6, 24. And which relation we have to apply here? Divides relation. And we have to mention whether this one is totally ordered set or not. So first of all tell me, draw a diagram and tell me whether this one is totally ordered set. Okay, first one I will explain. For next you have to try. Now here 2, 6 and 24, these are the elements. So 2 divides 6 and 6 divides 24. That's why these are placed in one chain. So this is called as totally ordered set because elements of this set forms a chain. Okay. Now try for second example whether this one is toe set. Hello. What about B? Whether this one is toe set?
Not toe set.
Not toe set. Why?
3 is not divided to 5.
Yes, 3 cannot divide 5. That's why diagram for this set is 3, 5 and these two elements divides 15. That's why 15 is placed at this place and 3 to 15 and 5 to 15 line is there. But 3 to 5 we cannot place any line because 3 cannot divide 5. So this does not form a chain of elements. That's why this is not a totally ordered set. Now consider next set C and it is consist of elements 1, 2, 3, 6 and 12. Now draw the Hasse diagram for this set and tell me whether this one is toe set.
Not toe set.
Not toe set.
Not toe set.
Yes, because Hasse diagram for this one is first element is 1, 1 divides 2, 1 divides 3. That's why these are connected by lines. Now for this 6, 2 and 3, these are the dividers. And again for this 12, 6 divides 12. That's why we can place a direct line between these two elements. Again, this does not forms a chain of elements. That's why this is not a toe set. And last one, it is consist of 4 elements, 3, 9, 27 and 54. So again 3 divides 9, 9 divides 27 and 27 divides 54. So it forms chain of element. That's why this is a toe set. So have you understood what is meaning of toe set?
Yes, ma'am.
Okay. Now second question, draw a Hasse diagram for this set, and this set is consist of elements 3, 4, 12, 24, 48, 72 and relation is divides relation. So take 5 minutes and draw a Hasse diagram for given set. So here first element is 3, next one is 4, but there is no any relation, that is divides relation between 3 and 4. So we have to place these two elements at separate place and there is no any line between these two elements. Now next one is 12. So 3 divides 12, 4 divides 12, that's why these are connected by lines. Next one is 24. So 12 divides 24 and this 24 divides both 48 and 72. That's why these are the lines. So this is the Hasse diagram. If your given set is consists of these elements and relation is divides relation. Okay. Now try for this next set. This set is consist of elements 1, 2, 3, 4, 6, 8, 12. Again, relation is divides relation. So here for this diagram, 1 divides 2, 1 divides 3, then 2 and 3 both divide 6. Next one, 2 divides 4 and 4 and 6 divides 12 and 4 divides 8. That's why Hasse diagram for given set will be like this. So I think this problem we have seen. Instead of this 1, 2, 3, we had written there ABC. So same problem is here. So again, these are some examples based on Hasse diagram. Consider question number 1. Draw the Hasse diagram representing partial ordering set consists of order pair A, B such that A divides B on this given set, which is consist of elements 1, 2, 3, 4, 6, 8 and 12. Okay. So this is given set and relation is a divides relation. So try for this example. And send that Hasse diagram on WhatsApp. Okay. I think we have seen this problem earlier. Okay. Same elements are there. Okay. Again, in this second question, 4 elements are given and these elements we have to place by using a relation less than equals to. Again, we have seen 1 is less than 2, again 2 is less than 3 and 3 is less than 4. That's why this diagram will be like this. Again, it forms a chain of elements. So, this is a toe set. So, I think all these examples we have seen. So now tell me, do you have any problem, doubt regarding Hasse diagram? Because surely you will get question on this either for 4 marks or 8 marks in final exam. समजलं का Hasse diagram काय आहे?
Yes, ma'am.
Yes, because
Yes,
we
ma'am.
have spent 2 lectures on this point only. Yeah, fine. So we are going to stop here. Next lecture we are going to start unit number 5, that is functions. Presently, roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3, 4,
Yes, ma'am.
5, 6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Yes, ma'am.
15, 16,
Present, ma'am.
17, 18, 19,
Present, ma'am.
20, 21,
Yes, ma'am.
22,
Present, ma'am.
23, 24,
Present, ma'am. Hello,
25,
ma'am. 70 present.
17. Okay. 25, 26,
Yes, madam.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
20. Okay. 35, 36, 37,
Yes, ma'am.
38,
Present.
39, 40,
Present, ma'am.
41, 42,
Present, ma'am.
43, 44,
Yes, ma'am.
45,
Yes, ma'am.
46, 47,
Yes, madam.
48,
Yes, madam.
49,
Yes, ma'am.
50,
Yes, ma'am.
51, 52,
Yes, ma'am.
53,
हॅलो मॅम त्याने चॅट बॉक्स मध्ये टाकलं.
हाँ, 54,
Yes, ma'am.
55, 56,
Yes, ma'am.
okay, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60,
Yes, ma'am.
61, 62,
Present, ma'am.
61%.
okay, 63, 64, 65,
Yes, ma'am.
66,
Present, ma'am.
67, okay, 67, 68,
Yes, ma'am.
okay, 68, 69,
Present, ma'am.
70,
Present, ma'am.
okay. Now check for absent numbers. Roll number 3, 5,
Ma'am, 3 present.
Ma'am, 5
Ma'am,
present.
7.
Hello, ma'am.
प्रेझेंट
15 is
घेताना कुठे
present.
होता मग रोल नंबर 3, 5, 7 मग
Ma'am,
रोल
15
कॉल
is
कॉल केले तेव्हा कुठे होता
मॅम मी गेली होती आवाज नाही आला.
रोल नंबर 18, 20, 21, 23,
हॅलो
25
हॅलो मॅम.
हॅलो
21 प्रेझेंट आहे मॅम. आवाज आला नाही मला.
36, 39, 41, 43, 46, 51, 55, 59, 63, 64 and 68.
59 is present, ma'am.
Okay, so today we will stop here. Thank you.